I already shared. I already shared the slide. Please see. Can you see the slide? Yeah, Azim, can you see the slide? Tam, can you see the slide? Okay, you can open Euler's method. Euler's method. Please open Euler's method. I already shared the slide. Somebody can share the slide in Microsoft Team? Mohammed Azli, can you share the slide? Hello? Can you hear me? Hello? Please reply. Hello? Hello? Can you hear me? Azim, can you hear me? Can you see the slide? Can you see the slide? Can you see the slide, Mohammed Nabil? Can you see the slide, please? Mohammed Nabil. Mohammed Nabil, can you see the slide? Please reply verbally. Please reply verbally.
Yes, sir. From my side,
Mohammed Nabil, you can see?
Yeah, I can see.
Okay, what you can see? Please read for me. Please read for me.
Chapter 0401 PDF Euler's method, right?
Red color, right?
Yes.
4.1 is a Euler's method, right?
Correct, sir.
And number 2, Yule's method. Number 3, fourth order Rangikuta method.
Yep.
So now today we do Euler's method. Okay? Hello? Can you reply me?
All right.
Can you share the slide to others? In Microsoft Team, yeah. If they have problem.
All right.
You can see the slide, right?
Yes, I can see.
You wrote, I don't know about others, but the slide is viewable from here. So I'm not hearing from others. What about Wei Wei? Wei Wei, can you see the slide?
Sorry, sir, the slide does not appear on my screen.
Who are you?
Irfan.
Oh, you ask Nabil. Nabil can see the slide. Are you in Microsoft Teams?
Yes.
You learn. You go to
Yeah.
You Learn. You click under my name. Today, 28. It's visible. You can see now the slide is there already. I already shared the slide. Why you cannot see? Mohammed Nabil. Mohammed Nabil.
Yes, sir.
Hello. Are you there?
Yes, I am here.
How you did? Because your friend cannot see it. How you did?
I do not know, sir. I just entered the class and there's the slide.
Hello. Others can hear you? Now you got to tell Mohammed Nabil is okay. The Azim, how are you, Azim? Can you see the slide, Azim?
Cannot, sir.
Are you in the wrong class, Azim? Hello, Azim. Azim, where you click, Azim? Azim, are you there, Azim? Azim. Hello, Azim. Hello. Hello, Azim. Azim. Can you
Yes, sir.
how you did? How you did? How you did? I mean, where you click? Okay, class. I have to continue. So open the file Euler's method. Today we are going to study Euler's method as a revision. So you can open up your PDF file. Okay. So today we are going to revise the Euler's method. Open up your PDF file in Euler. PDF. Open up your PDF file at Euler. Okay, you follow me, eh? So open up. Azim. Are you there, Azim?
Yes, sir.
Hello, Azim. You go to Euler, open up the file. Euler method.
Okay, sir. Okay, sir.
So because you cannot see, those who cannot see, you said I am in your class, but you cannot see the slide. Others can see the slide. Am I right? I think you have problem. Mohammed Aiman, can you see the slide? Chia? Okay, Prosotman can see. Cannot see. Mohammed Nabil. Mohammed Nabil. Are you there, Mohammed Nabil?
Yes, sir, I'm here.
So you can see the slide, right?
Yeah, but I'm not sure if it is lagging or just the screen.
No, you say just now Euler method, right?
Yeah, correct.
So you saw the Euler method, right?
Correct.
So shall we continue?
I think it's okay for you to.
Okay. So if you cannot see, you go to Euler. Somebody said it is loading. I think it is loading, sir. Shah, are you there, Shah? Shah. Are you there, Shah?
Yes,
Huh?
yes. Yeah, I'm here.
So you saw the slide, right?
No, I'm not seeing any slides.
Can you open in ULearn? ULearn method.
I open already.
Okay, so today we do Euler method. Okay? Hello? Coding, yeah? So today topic is Euler's method 4.1, yeah? If you have any question, you can stop me anytime. And then you can ask me anytime, yeah? In your meeting chat. So why Euler's method? Actually, we already finished fourth order Rangi-Gupta method. And chapter 5, we will start next week. So Euler's method is one of the important method. We can call it as a backbone for the Yun's method, Rangi-Gupta method. And we want to go into detail, try to solve some of the problem in a more innovative and creative manner. So slide 4, under 4.1. So what we want to know here is, I don't have the pen, so I use the what we call snapshot here. So I put it in a box. You refer to the box. Solve the IVP for ODE by using Euler's method. So why Euler's method? Because this is one of the fundamental basic method to solve the first order ODE. So that's why we want to study Euler's method. And when you study this Yun's method, again, you have to use Euler's method. But Rangi-Gupta method, since it's fourth order, so it is well developed from the first order, second order, third order. And as you know, we already mentioned that the fourth order Rangi-Gupta method is the enhancement of the Euler's method. So Euler's method, the formula is very simple. And why you want to study Euler's method is very hard to solve the ordinary differential equation, especially in this case, the first order, analytically. That means the analytical method, either it is very hard or it is not available, which you already studied. I can show you later. We solve analytical method such as separable, where you integrate respect to y and x, and you find the analytical solution. And second one is the exact, non-exact. And the third one is what we call the Bernoulli. This is before Bernoulli, that is a linear differential equation using integrating factor. You got to revise that because that is analytical method. Now we can solve the same problem or more complicated problem which cannot be solved by chapter 1. So that's why we call this an method, extremely important in the field of not only engineering, science, and business, management, finance, and so on. So the reason other than this is some of the complicated problem we cannot solve by using analytical method. So that's why at least this numerical method, here we call it the Euler's method or Euler's method, is very important. At least we can get some approximate solution. So how we got this formula for Euler method? So we don't go into detail how it was developed. We just mention that Taylor series. The Taylor series is the fundamental idea to develop Point. What is single point? This is called the x naught. Okay. So Taylor series expansion at x naught is a very long series. You see, it goes to infinite. Yx equivalent to yx naught plus hy dash x naught plus h square divided by 2 factorial y double dash x naught plus h cube over 3 factorial y triple dash x naught and so on. But for first order, we take this one only. For second order, you can go for y double dash. Because we just focus on first order, so we take this left-hand side is the output yx, and the right-hand side is yx naught plus hy dash x naught. So we interpret this later on into Euler's method in a different way. But we use this formula, yx equivalent to yx naught plus hy dash x naught. So you want to know what is yx? What is yx? And then what is yx naught? And what is what is y dash x naught? So we have three terms. Left-hand side, yx. Right-hand side, yx naught plus hy dash x naught. So generally speaking, this yx is called output. This is called final output. But in iteration method, every time you got to do the output. And it will keep on repeating until we stop at one iteration, the last one, which will be given in the problem. So yx is the output, yx naught with the initial input x naught. When I give you x naught, you can find yx naught. Or it is already given in the problem, x naught, and then we call the y is y naught, but they didn't write here y naught. Plus, what is hy dash x naught? This h is called, later on, it will be called as step size. Y naught is called dy dx. The dy dx is the differential equation, the first order, at the point x naught. But y double dash is the second order. So at the moment, we are not talking about second order. We only concern about the first order. So you will be familiarized with the first order. In the future, you can use this method to solve second order. This one is second order, and this one is the third order, and so on. So now, how we interpret this into Euler's method? Okay, please let me know if you have any problem here, understanding. If you have any problem, you let me know. So our problem, because the Taylor series is already there, we already taken the two terms in the right hand side. Now, how we want to develop the Euler method to solve this problem, that is dy dx equals to fxy. The Taylor's method, we have to truncating. That means we cut by truncating the second derivative term. That means you don't consider the second derivative, you just consider the first derivative. So this y dash is dy dx. This plug inside here. This is called the y dash x naught. X naught, normally they didn't write, but please write down x naught is called the initial input. Later on, we will call this as the initial condition. Just now, they use the word IVP. You see IVP. IVP stand for initial value problem. Slide number 4. So you move the slide, yeah? When I move the slide, you try to move the slide. So now the y dash, this y dash, we have to interpret as fx naught y naught. Y dash x naught is fx naught y naught. So at the point x1, then this fellow will become fx1 y1. Okay. So here, since is starting point x naught. So the dy dx, you have to calculate f x naught y naught. From where? From here. This one is given. So the method is very simple, very clear. And we generalize this. Now, this formula, we have to generalize. This is the general formula for Euler's method. You see the x here, xi plus 1. Normally, you don't here, they don't explain the I plus 1. You have to take note, what is the meaning I plus 1? This is the next I, the left-hand side. The right-hand side, you see here I. And then you see here I. And then there is a I here. See, this one is the iteration. You put I0, then this 1. The output at x1, but this one will be x naught, x subscript 0. This one x subscript 0, y subscript 0. They don't write it. You see, nowhere to be seen in the solution. But now you have to take note, what is the meaning of this equation? Meaning of this equation will be well explained in the iteration process. So the h is called what? H is called step size. Step size, h is b minus a divided by n. How to calculate? So ab is the interval, close interval, lower bound a, upper bound b. And n is called the number of interval. This will be given in the problem. So you take n, put inside here, and b is given, a is given. So you can find your h. And then the h also same as xi plus 1. This one, xi plus 1 minus xi. Same thing. Okay. So you can find h. After you found h, you put inside here. We want to calculate this output. Remember, yeah? This yxi plus 1 is the output. Output of what? The next output. This is the initial output. So you calculate the next output using the Euler's method. Now, this method also known as Euler-Cauchy method, just the name only, because it's developed by Euler and with his colleague Cauchy. But it is different from the analytical method. Also, we call it point slope method. Why point slope method? The point is the x naught. That is the starting point. Slope is because this is dy dx. You are solving that's why the word slope is there. Now, we want to show you the philosophy of these methodologies. This x is called input. This y is output. How the numerical method works? You start with xi, that means x naught. If it's the x naught, then the next x is x1. So there is a h here. The function is any polynomial. So this is the solution curve. So you have a predicted value. This one comes from Euler's method. This is true value, comes from analytical method, such as in chapter 1, chapter 2, chapter 3, even Laplace transform. We will show you later, the predicted value is not same as true value. The reason is, these two predicted method is different from the true method. Therefore, there is an error here. We can calculate the error in terms of value or percentage by knowing the differences. So we will show this philosophy later on in the calculation. So example 1. Please see example 1. Yeah, you can stop me at any time. Direct Tan is there already. You can ask any questions in your meeting chat. So example 1, you want to solve dy dx for x squared. This problem class can be solved analytically. I will show you later on. We can solve this problem analytically. But now we want to solve numerically. So this Euler method is called numerical method. We want to solve this numerically at x equals to 2. So we want to find the output y at x equals to 2. That is the question. Y at x equals to 2. So y at x equals to 2, but we must start from x1 to x2. Start from x1 to x2. N is 1. Number of interval is 1. And when x is 1, your y is 1. What is the meaning, class? Meaning is you are finding at x equals to, you want to find at x equals to 2. But you must start with x equals to 1. So you write this, put the line here. Start from x1, x2. So from x1 to x2, your h is b minus a divided by n. So b is 2, a is 1, n is 1. So 2 minus 1, 1, 1 divided by 1, 1. That is the answer. So you already found the what we call the h. H is, you can see the next slide. So this is the formula we are going to use. That's why you must understand the xi plus 1, the next. So here, x1 minus x naught is 2 minus 1, 1. So the h is 1. The same thing. 2 minus 1 divided by 2. Because x is 1 and x is from 1 to 2. So this equation is the formula for Euler's method. Yxi plus 1 approximately equal to yxi plus h fxi yi. What is the meaning y1, 1? That means the x naught is 1, y naught is 1. That is the meaning. X naught is 1, y naught is 1. So you calculate h, step size h, because you need h here. So h is b minus a divided by n. So what is your b? B is 2. What is your a? 1. What is your n? 1. How do we know? You go back to the problem. You see, n is 1. B is 2. A is 1. So you must memorize this formula. Otherwise cannot. So your h is 2 minus 1 divided by 1. So h is 1. Now, your f xi yi, for the xi is the x naught, is 1. When x is 1, your y is 1. So you calculate fxy, 4x squared. 4x squared equals to 4 multiply 1 squared is 4. Now you substitute inside this equation. This yxi plus 1, the xi plus 1 is the x1, is the next x. So the next x is 2, from 1 to 2. So the next x is 2. Y equals to yxi, the previous x naught is 1. H is 1, F1, 1. So y at 2 equals to y1. Y1 is 1. Y of x1 is 1, given already, this one. So you put it here, 1. H is 1, F11 is 4. 4 is here. So 4 multiply 1 4. 4 plus 1, 5. So at y equals to 2, the answer is 5. So y2 is 5. Any question, class here? So in this case, your y output, yeah, y at 2 equals to 5. So we already found the output yx equals to 5. Okay, now we want to investigate. We want to investigate the h, the exact solution. The exact solution for this, you see y2 is 5. So if you solve this problem analytically, dy dx, if you solve dy dx, you separate using separation variable, dy equals to 4x squared dx, using the separable. So you find your dy equals to 4x squared dx. So if you solve this equation analytically, you get y equals to 4 over 3 x cubed plus c. So when x is 1, Roger Wong. Can you mute the, Roger Wong, any question? Roger Wong, you have any question? Hello? Okay, so when x equals to 1, your y equals to 1. This is the initial condition. When x equals to 1, y equals to 1. So if you substitute inside the equation, you get c equals to, the capital C equals to negative 1 over 3. Am I right, class? Hello? Please answer me. Abdul Anan. Abdul Anan. Hello, Abdul Anan. Are you there? Chia. Do you agree with me, Chia? Hello? Please answer my question, class. Hello, Chia. Yeah. Can you answer verbally? Verbally. Can you reply verbally? Yes or no? Is that correct? Hello? Kavinesh, are you there, Kavinesh? Hello, can you reply? So your analytical solution now, the analytical solution is y equals to, you substitute back 4 over 3 x cubed minus 1 over 3. So this is exact solution. So at y equals to 2, just now you get 5 numerically, Euler method. But now you substitute x equals to 2 inside this equation. Substitute x equals to 2. So you will get y at 2. The answer is 10 1 over 3. Am I right, class? 31 over 3. Yes or no, class? Please reply, yeah? Patricia. Farasha, okay. Now we have a problem. Do you agree y2 5 is equivalent to y2 10 1 over 3? Do you agree? So the answer is very far, right? Hello? Yes, sir. So far, yeah. Therefore, we need to use different edge. We need to use different edge. We are going to solve the same problem. Now I want you to use the edge. So we want to solve for h equals to 0.5. So in that case, we take our n is 2. Same problem, class. Just now n is 1. N is 1. Just now the same problem, n is 1. That means this interval is very big. So you substitute n is 2. So if n is 2, your h equals to, please follow me. If n is 2, your h is b still 2. We want to calculate at y2 because you say just now is very far. So your h now b minus a divided by n. So you should get 0.5. How do you get 0.5? 2 minus 1, write down, yeah? H is 2 minus 1 divided by 2. I want to hear your voice. Could you please reply me? B minus A, 2 minus 1 divided by 2. So we increase the interval 2. N is 2. So 2 minus 1, 1. 1 divided by 2, 0.5. Now H is 0.5. So your interval now, your x naught is 1. Your x1 is 1.5. And your x2 is 2. So you can find x naught given already, x1 1.5, x2 we have to find. So we will get different answer now. Can you do this now with your calculator, Roger Wong? Take out your calculator. At x equals to 1, y1, we know already. Now you want to calculate y at 1.5. We want to calculate. Because we have 2 interval now. So we have to do 2 iteration. X naught 1, y naught is 1. Is given already. So now we want to find x1 is 1.5. we want to find your y1. So you calculate y1.5 equals to y1.5 equals to y1 1 plus 0.5 multiplied by f11. F11 is 4. So this will be 0.5, sorry, 0.5 multiplied by 4. So this will give you the answer 1 plus 2. 1 plus 2 equals to 3. So at y, 1.5 is 3. Now you calculate y at 2, the next one. So y at x2 is equals to y at 1.5, that is 3 plus 0.5 multiplied by f of 1.5, 3 is equivalent to 4 multiplied by 1.5 power 2. So you calculate now. 3 plus 0.5 multiplied by 4x squared, 1.5 squared. So that is 2.25 multiply 4 multiplied by 0.5 plus 3. So you should get equals to 7.5. Yes. Yes. Yeah. Very good. Yeah, all of you must calculate. Yeah. So class, now y2 7.5. Just now when h1 y2 is 5. Now at h 0.5 your y2 is 7.5. Is 7.5 close to 10 1 over 3? The exact answer is y. Exact answer is this one, 10 1 over 3. So is 7.5 close to 10 1 over 3? Yes or no, class? Please answer my question. Yes or no? Please answer the question. I think no. Yeah, who is that? Patricia. Yeah. So class, now we want to do, now, yes, now keep on doing, your n now increase to 4. So your h now, because 7.5 is very far, so we have to investigate furthermore how we can get closer to the 10 1 over 3. So now your n is 4. So So your h is 2 minus 1 divided by 4, 0.25. Everyone take out your calculator. Now you calculate. Please, now you calculate. We want the answer now. So, at y1 is 1, you calculate at y1 at x 1.25. So you have to calculate 4 times. What is your y? When your x is 1.25. Calculate, yeah? So you must calculate. And then now you have to do the experiment, yeah, class. You have to do the experiment. You know y1, 1. So you calculate x at 1.25. And then you calculate y at x equals to 1.5. You calculate, yeah? Repeat the value. So we have to do 4 times. You calculate y at 1.25 and y at 1.5 and calculate your y at x equals to 1.75. You have to calculate now, yeah? Calculate. So you calculate y at x 1.25 and then use that, calculate y at x 1.5. And then use that y, calculate another y at x 1.75. And then the final one at x equals to 2. What is your y? I'm waiting for your answer now. Please give me the answer. Shah, I'm waiting for your answer to confirm my answer. Yeah. What is your value of y at x equals to 2? So you have to do 4 iteration. Start with x 1.25, calculate y, and use that y, calculate another y, second iteration at x 1.5. And after that, use that y, third iteration at x 1.75. And then use that to calculate the fourth iteration at x equals to 2. What is your y? Yes, Chia. Chia, what is your answer, Chia? What is your why? Shah, Purushothaman. Can you answer, Purushothaman? Mohammed Shah Lihin, Sunijit Singh. What is your answer, class? No, answer is wrong. Cannot be. Anyone else? Mohammed Shalihin, 8.875. Yes. Chow Jit. Y equals to 8.875. Yes. 8.875. So 8.875 is near to 10 1 over 3. But still, we need improvement. So if you want to get closer to 10 1 over 3, I have a suggestion. I have a suggestion for you. You got to increase the number of interval. Increase the number of interval. So one of the best way to do is, but this one, it will take a very long time, but you can try. So this is homework, yeah? Are you satisfied? Are you satisfied with this answer, 8.875? How did? Are you okay with 8.875? Hello? So in engineering point of view, is that 8.875? Is this answer okay with you? Mohammed Salihin, Chaujit, can you answer me? So now the question is how to get to 10. This is investigation class, new discovery. So there is a homework now. Not here. So your age, we want to go into detail, but this one you got to do 10 times. We still use B minus A divided by your age just now is 4. 0.5. So 0.25, right? 0.25. Now, if I go for 10 interval, then this will become 1 over 10, that is 0.1. So this is your homework. You can let me know next lecture. What is your y at x equals to 2 with h 0.1? That means you have to create a table, or you got to do 10 times. From 1 to 2, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and 2. So you got to do 10 times iteration, and then you calculate y at 2. Given x1, y1. This one we don't do it here, class. We do not do it here. We do not do it now. You are not replying verbally. Please reply to me verbally. I'm interacting with you. Shah, Mohammed Salihin, Chaujit there. Chaujit. Hello. Can you reply verbally? Hello. Mohammed Salihin. So as a homework, you can try. This is the disadvantage of this Euler's method, because we did for h 0.25 and we calculated y2 still 8.875, and we come to conclusion that 8.875 is still not close to 10.33, because 1 over 3 is 10.33. So one way to get closer to 10.33 is to reduce the h. We started with h1, h 0.5, h 0.25, the last one h 1.0. But if you reduce the h and increasing the number of interval, meaning you have to do a lot of iteration. Here you have to do 10 times. So this is time consuming by manually. Manually, if you want to do, it will take a very long time. Of course, that's why we have programming. If you can program, and then you can use the programming software, you can calculate. But still, if the problem is very complicated, then it will be very hard as well. That's why we need a method as Yoon's method to get approximate as well as accurate solution within less number of interval. In this case, Runge-Kutta method is one of the best method. This problem now can be solved by 4 methods class. But the comparative method is called the accurate method. So you can see here, go back to the slide, the predicted one is not same as the true. So even at H 0.25, you get Y2 8.875. That is predicted one. But the true value is 10.33. 10.33. So 2 decimal place. Or 3 decimal place, 10.333. So we can go up to H 0.25. That is, you did for 4 intervals, right? 4 intervals, 0.25. So now we can increase. That's why we want to increase the number of interval and reduce the H. So as a homework, you try for H at 0.1, and next week you can give me the answer at Y equals to 2 is what? Hopefully, we don't know the answer yet, unless among yourself, if anyone already done, but it is not possible at the moment because you have to do 10 iteration. That means Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, and then Y9. So, sorry, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, Y9, Y10. So the Y10 is the one we want to know with H 0.5. This is one of the most challenging problem to investigate the philosophy of this concept. So that's why the Euler method is considered as time consuming. Any question, class? Any question, class? Sorry, sir, my mic have some problem. Muhammad Salhin. Okay, sir, no worry. I will try it. Yeah, Amirul. Any question? Any question so far? Today we do a kind of tutorial to investigate. This is called new discovery. To train your mind, new discovery to train your mind to be more innovative and creative. So the creativity here is how to get accurate solution. So in the example, we are moving from Y25 with H1, and then at H 0.5, Y2 7.5. At H 0.25, you got Y2 8.875. And you are not satisfied with this 8.875. Therefore, one of the best possibility is to reduce the H. So this is what we call new discovery, new invention, because it is not possible to do H 0.1 with the time constraint. So normally what you do, you stop at 8.875 with certain percentage of dissatisfaction, because you want to get a more accurate answer, accuracy. So in order to get more accurate answer, you have to increase the number of iteration. The word iteration is missing. Iteration. This is iteration method. So if you do 10 times, if you do n equals to 10 times, it's a good exercise class. 10 times, there is a possibility you may get a good output. This is investigation class. So, but you have to work very hard. It's not easy, because 10 times you start with x equals to 1, y equals to 1 given. So what is next? X 1.1. What is your y1? After you calculated y1, the next x is 1.2. What is your y2? After you calculated y2, the next x is 1.3. What is your y3? After that, at x equals to 1.4, what is your y4? After that, at 1.5, what is your y5? You keep on doing until x equals to 1.9, what is your y9? And the last one is x equals to y is what? That is the most challenging problem, and it will be very interesting for you to get the value at y2. H is 0.1. Let me know the answer. What is your y? H 0.5. What is your y2? Very interesting problem, class. I don't want you to do now. You can do it at home later when you have time. Try. And you come out with the table, 2 columns, 2-column table. Left hand side, your input x start from 1, y 1, x1, y1. Then the second row, 1.1. What is your y? Third row, 1.2. What is your y? Fourth, 1.3. What is your y? Like that, you go until x 1.9. What is your y? This is one of the most best solution ever solved in this chapter. This is the best we can do. If you still cannot get 10.33, then we have to move on to a new method. That is what we call Yoon's method. But in this case, as I said, you can solve analytically. We already solved this problem analytically. Answer is 10.33. And take note, yeah? Answer is 10.33 at x equals 2. Your y output is 10.33. That is analytical method using separable method, which you studied chapter 1. So you already have y 10.33 at x equals to 2. Analytical method. Now method number 2, you use Euler method. Method number 3, you can still use Yoon's method. And method number 4, you can use Rangekota, RK. So these four methods, you can compare the answer. Huh? So you studied now already 4 methods. Altogether 4 methods. Write down, yeah. First one is separable method. Second one is a Euler method. Euler, Yuns, Rangekota, we call it as a numerical method. Numerical method. And the analytical method, which we obtain y 10.3333 at x equals to 2 is called the separable method. Separable method is what you studied in chapter 1. In this case, the philosophy goes like this. The philosophy here is this problem, the dy dx. I'm going to explain in detail. Yeah, the dy dx problem can be solved. This problem can be solved analytically. So the advantage here is you can compare how good Euler method compare with the separable method. How good. That's why just now we were caught. We were caught because we cannot get 10.33 with h 0.25 with the 4 iteration. So we have to increase to the 10 iteration, hoping that we can strike 10.333. But it is very hard. Euler method. So in this case, class, if you do 10 times, still you cannot achieve the y output 10.333. You have to use Yuns method. You try. This is extra exercises. If Yuns method still fail, cannot get 10.333 at the moment, yeah, you can try Rangekota method, RK. If still Rangekota method fail, then only we go for artificial intelligence methods. Artificial intelligence methods such as fuzzy logic, you can write down for your postgraduate studies, masters and PhDs. Fuzzy logic, F-U-Z-Z-Y, L-O-G-I-C, fuzzy logic, number 1. Number 2, we use artificial neural network, which we call it ANN. Number 3 is called genetic algorithm, GA, short form. The first one is FL, philosophy of artificial intelligence. These are the methodologies invented in the years 1965, fuzzy logic, artificial neural network, 1980s, and genetic algorithm, 1990s. So this method, artificial intelligence method, is very important. This is the advanced method to solve the differential equation, which is very, very complicated. And accuracy is the major problem. So in order to improve and enhance the accuracy, AI plays very important role. And under AI, there are many categories. You have computational intelligence methods, machine learning methods, intelligent systems, expert system, meta-heuristic, many, many methods. I just gave you the 3 very famous fundamental methods. You can study these for your masters and PhDs. One can do MSc in fuzzy logic, PhD in fuzzy logic, MSc in ANN, PhD in ANN, MSc in genetic algorithm, PhD in genetic algorithm, as well as postdoctorates. And it can go up to other levels as well. And the application is very important in engineering, especially in finance, economics, and then in business, and more importantly in computer science, as well as management. So we have a course like financial engineering. Financial engineering, you can use these methods to solve the financial engineering problem. Also, we have engineering management courses. We can use this method to solve engineering management problems. So, what is the advantage of numerical method, Euler, Yunus, Range-Kota? The advantage is at least you can solve the problem approximately with certain percentage of the error. The good example is just now, at x equals to 2, the analytical solution is 10.33. Now we calculated the y2 with h 0.25, 8.875 is not same as 10.33. But at least you have the answer, 8.875. But we can improve that at h 0.10, and then you calculate your y. And this is where the computer software programming is very important. You can write, get the answer from the programming. As I said, if the Euler method fails and you are not satisfied with the answer with h 0.10 after getting y, still you can go for Yunus method. This is homework. It's a good exercise. You can consider this as a tutorial question. Try the same problem, x 1 to 2, but h is up to you. H actually, in this case, the first one is h1. This is a simple example, but not good answer. And then h 0.5, you are still not satisfied. And at h 0.25, still we strike 8.875. And next, we want to investigate at h 0.1. This is the last option. If you want to reduce some more, h 0.01, then the number of interval and number of iteration will be increased. That will give you a problem of time constraint. That's why we use Yunus method and RK method. So that is for today. Example 2. So today I just want to discuss example 1 with the tutorial type. Tutorial type so that you can build up, strengthen the Euler's method and do exercise. Later on, there will be a question. Exercises will be posted via Euler. You can try. So any question, class, so far? So just now, who answered? Mohammed Akil answer ready. Mohammed Salizan answer ready. Adam, yeah. Any question? Yeah. BH, any question? BH, any question, class? Any question so far? Patricia? No reply from you? Chia, any question, Chia? Any question, Chia? Any question, Chia? Thank you. Kavinesh? Kavinesh, any question? Sir, do the tutorial have marks for coursework? No, sir. No mark. Yeah, only quiz. Only quiz. Sorry. We already finished quiz 1. Quiz 1 finish. Assignment finish. You wait for quiz 2, the last one. After that, final wait for quiz 2. That's one. Yeah, so we already finished quiz 1. I hope you already have the marks. And then assignment 1. Next, we are preparing quiz 2. Quiz 2 will be on chapter 3 and chapter 4. Quiz 3, Laplace and Euler. Test 1. Yes, Sunijit Singh. You can contact Dr. Mohna. Sunijit Singh, sir. Laplace transform. Quiz 2, Laplace transform. Oh, sorry, quiz 2. Quiz 2, Laplace. Three questions. Sunijit Singh. Suniljit Singh, yeah. Farah Shah, for quiz 2. For quiz 2, sir, what topic? Laplace transform. And then Euler. When will be our test 1 be, sir? Test 1, Sunijit Singh, yeah. Please contact the coordinator. Any question so far? Sorry to interrupt, sir, but when is quiz 2? 8th or 9th week? Young, yeah, 9th week. In preparation now. So just prepare Laplace transform, inverse Laplace transform, and then Euler method. We will do 1 or 2 iteration, maximum 3 iteration. So maybe about 40 to 50 minutes. So next week, we hope to start chapter 5 next week. Still, we have ample of time. But we will do the revision on Yoon's method and Rangikota method. So I want to know more questions from you on Euler and Yoon's method and Rangikota. So before we stop, for the example 2, x0, x4, step size 0.5. Actually, this problem, you have to solve H0.5. This is 0.5 means 0 to 4, 8 intervals class. X0, 0 to 4, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. So they just solve for 1 only. And then the answer given is 5.25. So this is another exercise. This problem actually can be solved analytically. You can investigate class what I have done. You can integrate dy respect to dx and put x0, y1, find the c, and then at x equals to 0.5, you can find your y. So what we want to know here is, can you do the table x0, y1, x0.5, y is 5.25, already obtained. And then x equals to 1.5, x equals to 1, what is the value? And 1.5 until 3.5, and the last one is 4. So you have to create the table. You create the table. You create the table, 2-column table. So, and then you put, what is that? All the rows and column. You can do all your own investigation. All right. So I already showed to you how to improve. But in this case, no need to do any improvement, because H0.5, you have to do 8 iteration. Because your H is 0.5. So B minus A divided by N, that means N is 8. 4 minus 0 divided by 0.5. So 4 multiplied by 2, 8. So you have to do 8 iteration. But it is not guaranteed after 8 iteration you get the accurate result. And this is called non-guaranteed method. Nothing is guaranteed. Just trial and error, you try. That is what we call the limitation of Euler's method. Limitation of Euler's method. That much only the strength of the Euler's method. That's why we need another method, predictor corrector method, to get more accurate. The whole philosophy is about accuracy. How accurate you can get the answer numerically. But this problem all can be solved analytically. That is the main important thing, because right hand side all x. So you can integrate respect to x. You substitute x0, y1, you find the c. And then the trick is the h. Our discovery tells us in the previous example, you can reduce the h in order to get the accurate result. But keep on reducing the h doesn't mean that you will get exact answer. That also not guaranteed. You try, you go according to the iteration, and then you review your output and then see the error, how much is the error. The difference is the error. The error is actually, you want to calculate percentage-wise, can. So how to calculate? The predicted true, this can be up and down, not necessarily the predicted always high. The true can be high and then predicted. So we take the modulus. In this case, predictor minus true divided by true multiplied by 100%. So you get the percentage of error. Or true minus predicted. Normally true minus predicted divided by true multiplied by 100%. You get the percentage of error. That's how we calculate the percentage of error. T minus P divided by T multiplied by 100%. You studied in engineering mathematics 1 how to calculate the percentage. Okay, any question, class? I know. Any questions? Please fill up satisfaction poll. Yeah. Please fill up satisfaction poll. We need 70. Yeah. Yeah. Any question, class? Any general question?
No, sir, no.
No. Oh. Okay. Yeah. So far, any question? Yeah. Yes, please. Before we stop. Next week we start chapter 5. Yeah. We can go slowly because chapter 5 is about numerical method. I think this is about PDE, partial differential equation. Also, we solve numerically. That's why you have to establish the foundation of numerical method. The same. If you have already done, it's okay. Once a week only, once a week only, the same one. If you already done, thank you. If you already done, thank you. Chair. Thank you, Chair. So class, any more question, class, before we stop? Any more question before we stop? Shall we stop now? Sure. Yeah. Shall we stop now? Hello? Yes, Muhammad Nabil. Are you okay, Nabil? Muhammad Nabil, are you okay? Muhammad Nabil.
Yes, I'm good.
Okay, good, sir. Thank you. Thank you. I can see your photo. Huh? Very nice photo. All right. So, okay, that's all for today. So I stop here.